All right, and then finally here we have simple lipids. You'll see, in my opinion, they're not as simple as the other complex lipids, but whatever. The first classification are steroids. And so these have 3 6-membered rings and then 1 5-membered ring. So these are often called A, B, C, and then D for the 5-membered ring. So has 6-membered rings are cyclohexanes, and there's 3 of them, and then there's a 5-membered ring. And there's 1 of them. Your textbook, and of course you can look online, has a really cool example of cholesterol synthesis. Cholesterol is a steroid. This is from squalene. It's a very cool looking synthesis because you go from this relatively linear hydrocarbon to this kind of complex with lots of rings. Take a look at it there. Other steroids, right? These are like kind of our sex hormones. It's like testosterone is a very popular one. And there's other steroids as well. They're mainly messenger molecules. So they're oftentimes made in one part of the body, and then they go to other parts of the body and they tell that part of the body to do something. The other main type of simple lipids is our prostaglandins. They have this kind of overall type of structure. It's not exact, but we always have a 5-membered ring. We have some kind of oxygens bound to them. They can be carbonyls or alcohols, depending on which one. Carbonyl is more common. These are grouped, or sometimes there can be alpha beta unsaturated, right? So there can be alkenes here as well. And then R groups can obviously be something else. They are also biochemical regulators. So very similar to steroids in that there's some kind of signaling compound. Usually the difference is steroids are made in one part of the body and then travel to other parts. Prostaglandins are kind of more local. They're made in the same part, but they kind of signal. They're very common for like damage / injury. So they're part of that kind of response system, you know, when you get a bruise or a cut or something like that, they help signal, you know, hey, let's take care of this body. And then finally, we have terpenes. So all terpenes are some sort of derivative of isoprene, which looks like this. However, the terpenes end up looking not anything like the isoprene. So for example, I forget which one this was. I think this is menthol. Don't quote me on that though. There's one of them. It's kind of hard to tell how isoprene became this molecule, but it did. And the easier kind of way to tell whether something is isoprene is A, does it look like one of these other ones? If not, then it's probably an isoprene. And then note that this one has 5 carbons, and then all of our terpenes are going to be derivatives of 5 carbons. So, right, they'll either have 5, 10, 15, 20, 25, that kind of thing. So multiple of 5 carbons, and they're more often found in plants. Again, this is just a very brief, very brief overview. Biochemistry, very cool topic, very complex topic. If it's interesting you, go ahead, read more or take another course about it.